Hey developers, and welcome to the core mechanics of AI's next evolution. In this series, we're diving deep into the tech shaping tomorrow's AI landscape, starting with something truly transformative, the multi-component protocol, or MCP. You might be thinking, okay, another protocol, what's the big deal? Well, think of MCP as the universal adapter and common language protocol for AI components. Just like USB-C finally unified a jumble of proprietary chargers and ports into a single, seamless connection for your hardware, MCP aims to do the same for diverse AI systems. It's a standardized interface and communication layer, designed to let disparate AI models, agents, and services speak to each other effortlessly, regardless of their underlying frameworks or architectures. Its core concept? To define a consistent way for AI components to discover, interact with, and exchange data, making interoperability a fundamental principle, not an afterthought. In real systems, this shows up when you're trying to integrate, say, a Python-based NLP model with a Java-driven recommendation engine, and then connect both to a Rust-compiled decision-making agent. Traditionally, each connection requires custom API wrappers, data transformations, and bespoke authentication, a nightmare of glue code. MCP abstracts all that away, providing a uniform syntax and semantics for requests and responses. It's about more than just data formats. It standardizes the intent and context of AI to AI communication. This means an AI agent can issue a high-level command like "analyze sentiment on" this text to any compliant NLP service without needing to know the specifics of its API or internal workings. This is foundational to building truly composable AI. Essentially, MCP is giving AI components a common tongue, moving us from fragmented, tightly coupled integrations to a modular plug-and-play ecosystem. It handles the low-level handshake and data choreography so you, as the developer, can focus on the higher-level logic and agent orchestration. This abstraction significantly reduces development overhead and accelerates the deployment of complex, multi-agent AI systems. We're talking about enabling true AI service mesh architectures. But how does this translate into solving your daily integration headaches, particularly around security and granular permissions for AI agents? That's exactly what we'll unpack in our next scene. Alright, so we've defined MCP as that universal adapter for AI. But why do we even need a universal adapter in the first place? What problems is it actually solving for us developers? Currently, integrating diverse AI components into a cohesive system feels a lot like navigating a maze built from proprietary APIs, disparate data formats, and a tangle of custom SDKs. You've got a cutting-edge LLM here, a specialized vision model there, maybe an agent orchestrator somewhere else. Each one speaks its own language, demands its own authentication dance, and requires bespoke glue code to make it talk to the others. You might be spending more time writing boilerplate and managing API versioning nightmares than actually building innovative features. And for AI agents, granting them granular permissions securely across different systems without exposing sensitive credentials or overprivileged keys becomes a significant, often precarious, challenge. This is exactly where MCP steps in, acting like that universal adapter and common language protocol for AI components, turning a jumble of proprietary plugs into a single, seamless connection. Instead of writing custom converters and authentication wrappers for every single interaction, MCP provides a standardized interface. In real systems, this shows up when a team I know was spending 30% of their sprint cycles just integrating a new AI service, only for it to break when the vendor pushed an API update. MCP aims to abstract away these underlying complexities, letting you focus on the logic of your AI applications, not the plumbing. Its architectural design isn't just about convenience, it's about fundamentally rethinking how AI systems communicate and operate. By providing a common protocol, MCP drastically reduces the boilerplate code needed to orchestrate AI agents, allowing them to interact securely and efficiently. This means less time debugging obscure integration errors, more robust security for AI agents, with clearer permission models, and an overall quality of life improvement that moves us beyond the good enough of current API/CLI approaches. It streamlines the development workflow, making AI integration a declarative task rather than a custom coding marathon. This foundational shift empowers you to build more complex, reliable, and secure AI systems faster than ever before. Next, we'll dive into the core architectural principles that make MCP's magic possible. Alright, so we've established why MCP is a game changer, solving those integration headaches. Now let's peel back the layers and look at how it's built. its core architectural principles. At its heart, MCP is all about modularity and interoperability. Think of it like this. Just as a standard USB-C port lets you connect all sorts of different devices, monitors, chargers, external drives, MCP is designed to be that universal adapter, that common language protocol for all your AI components. Instead of building bespoke connectors or writing custom glue code every time you want an LLM to talk to an image recognition model, MCP provides standardized interfaces. It means you can swap out components, upgrade them, or add new ones without rewriting entire systems. This flexibility is crucial for future-proofing your AI architecture, making development faster and far less brittle. But seamless connection isn't just about the physical plug, it's also about speaking the same language. That brings us to MCP's communication protocols and data exchange formats. Imagine a multinational conference where everyone suddenly understands each other perfectly, no matter their native tongue. That's what MCP enables for AI. It dictates a unified way for agents to send and receive information, ensuring data integrity and consistency across your entire AI stack. You might be thinking, don't we already have APIs for this? Yes, but MCP abstracts away the specifics, making interactions genuinely semantic and intention-aware rather than just endpoint calls. In real systems, this shows up when you need an autonomous agent to, say, pull data from a legacy database, process it with a cutting-edge vision model, and then generate a report, all without complex, fragile transformations in between. Now, let's talk about something incredibly important that resonates with many of you, especially given the concerns on platforms like Reddit: security for AI agents. The ability to grant granular, secure permissions is paramount. We've all struggled with managing IAM keys or service accounts for automated tasks, knowing the inherent risks of overprivileging. MCP is designed with a robust security model from the ground up. It implements a principle of least privilege by default, allowing you to define extremely fine-grained access controls for each AI agent, down to specific actions on specific resources. Picture an AI agent needing to interact with a bash command or an AWS IAM role. MCP provides a secure, auditable layer that can manage those permissions dynamically, ensuring that an agent only ever has the exact access it needs when it needs it, and nothing more. This mitigates significant security risks and brings a level of control that traditional methods often struggle to deliver, offering genuine peace of mind for developers. So how does this refined control translate into tangible benefits for your projects? So we've laid down the architectural blueprints for MCP. But what does all that theory actually mean for you, the developer, in your day-to-day work? How does it make things tangibly better, offering quality of life improvements over existing methods? Let's talk about the specific technical differentiators that are going to simplify your AI development journey. First up, it's about making your life easier with streamlined integration and a truly unified API surface. Think about it. Right now, integrating different AI models, services, or platforms often feels like you're trying to connect a dozen different types of plugs into incompatible sockets. Each one has its own specific API, its own authentication quirks, its own data formats. MCP changes that by being the ultimate universal adapter for AI components. Instead of wrestling with a jumble of proprietary plugs, you get a single, seamless connection. This means fewer custom API calls to learn, fewer bespoke connectors to build, and a much more consistent way to interact with any AI component, no matter its origin. It's a huge quality of life improvement, letting you focus on logic, not integration headaches. Now, let's tackle a big one that often comes up in developer discussions, especially on Reddit. How do you securely manage and grant granular permissions to AI agents, particularly when they need to interact with system commands or cloud resources like AWS IAM? You might be thinking, traditional IAM is already complex. How does AI add to that? MCP provides an elegant solution. It introduces an abstracted security layer, specifically designed for AI agents. This isn't just about passing along an API key. It's about enabling fine-grained, auditable access. In real systems, this shows up when an AI agent needs to update a database, access a specific bucket in S3, or even execute a bash script. MCP's security model ensures that the agent only ever has the absolute minimum permissions required for its task, the principle of least privilege, and that every action is logged and attributable. This dramatically reduces your attack surface and gives you far greater control and visibility over what your autonomous agents are doing. No more handing out wide-open keys and hoping for the best. Beyond simplification and security, MCP significantly improves the flow of data between disparate AI components. Imagine you're building a complex AI pipeline, maybe a vision model feeding into a natural language processor, which then instructs a generative model. Each of these might have its own preferred data format, its own communication protocol, MCP acts as that common language protocol, ensuring all these diverse AI components can understand each other without constant messy data transformations. It's like having a universal translator embedded in every connection, turning a jumble of proprietary plugs into a single seamless connection where data just flows. This dramatically reduces latency, cuts down on computational overhead from endless data wrangling, and accelerates your development cycles because you're spending less time translating and more time innovating. It's about making your AI ecosystem truly interoperable. So we've seen the tangible benefits: simpler APIs, stronger security for your agents, and seamless data flow. But how does this all actually come together? In our next scene, we'll start exploring the basic ecosystem and core concepts that enable MCP to achieve all of this. So we've established that MCP is this powerful universal adapter for AI components, turning a jumble of proprietary plugs into a single, seamless connection. But what exactly are these plugs and the broader ecosystem around them that developers will be interacting with? Understanding the landscape isn't about diving into specific code just yet. It's about mapping the core concepts and fundamental building blocks that will either feed into MCP, leverage it, or help manage it at scale. You might be thinking, okay, so MCP connects everything, but what exactly is it connecting, and what tools help me do that? Let's break it down. First, you have the foundational AI components themselves. These are the diverse models and data sources that MCP is designed to unify. We're talking about everything from large language models, your LLMs, to vision models, speech recognition systems, and specialized expert agents. Then there are the data connectors, which are crucial for feeding these models with relevant, high-quality information from various databases, APIs, or streaming sources. These are the raw inputs, the diverse proprietary plugs that MCP streamlines. Supporting all this are the inference runtime environments, the dedicated spaces where these models actually execute and generate their outputs. This initial layer is where all the disparate AI, brains, and memories reside, waiting to be connected. Moving a layer up, we find the developer tools and integration points that make working with MCP practical and efficient. This includes official MCP client libraries, or SDKs, which will provide the standardized interfaces for your applications to programmatically interact with MCP. I've seen teams wrestle with stitching together custom wrappers for different models, often leading to brittle code and security headaches. These SDKs aim to eliminate that. Furthermore, you'll find dedicated AI agent orchestration frameworks. These are crucial for managing complex workflows where multiple AI agents connected via MCP need to collaborate, delegate tasks, and maintain context across operations. And, importantly, there will be security and access control tools that abstract and manage granular permissions for these agents, directly addressing concerns about secure interactions with system resources. Think of these as the specialized wrenches and meters you use to work with the universal adapter itself. Finally, we have the operational infrastructure that supports MCP-enabled applications in the real world. This largely involves your standard cloud and edge deployment platforms, whether you're running on AWS, Azure, GCP, or on specialized hardware at the edge. Containerization technologies like Docker and Kubernetes will play a huge role in packaging and scaling your MCP-integrated AI agents, ensuring they run consistently across different environments. And, critically, robust monitoring and observability platforms will be essential. These tools allow you to track the performance, reliability, and security of your MCP orchestrated AI ecosystem in real time, helping you debug issues and ensure everything is running smoothly. Understanding this broader ecosystem is key, because while MCP simplifies the connections, it still operates within a complex technical landscape. So, what happens when things don't go as smoothly as planned? We'll look at some common developer watchouts next. We've just mapped out the MCP ecosystem, and it all sounds promising, right? But let's be real for a moment. Every new technology, no matter how revolutionary, comes with its own set of watchouts for developers. You might be thinking, my current REST APIs and CLI tools are good enough for managing AI models. Why rock the boat with yet another protocol? This sentiment is understandable. It's the natural resistance to change, especially when existing methods seem to get the job done. But good enough often hides subtle inefficiencies, security gaps, and scalability limits that only become apparent down the line. The initial hurdle of learning something new, adapting workflows, or refactoring existing integrations can feel daunting, but dismissing MCP too quickly could mean missing out on significant quality of life improvements. Beyond that initial mindset shift, there are practical integration hurdles we need to acknowledge. Imagine you're trying to connect a cutting-edge AI model with a legacy data pipeline, or perhaps you're wrangling with unique, proprietary AI components that don't play nicely with anything off the shelf. This is where compatibility issues can pop up. You might face challenges ensuring your niche AI models or even older custom scripts can fully leverage MCP's capabilities without extensive re-engineering. It's like having a bunch of different power plugs, and while MCP aims to be that universal adapter, some old devices might need an extra step or two.
In real systems, this shows up when teams struggle with schema evolution. How do you gracefully adapt your data structures as MCP evolves without breaking existing integrations? It's a common headache that needs proactive planning. So how do we mitigate these potential roadblocks? First, don't try to rip and replace everything overnight. Start small. Identify a specific, isolated AI agent or component that could genuinely benefit from MCP's unified protocol and integrate it incrementally. Leverage the emerging community and official documentation. Chances are, someone else has faced a similar challenge. Crucially, prioritize security from day one. Remember our earlier discussion about granular permissions for AI agents? MCP, when implemented correctly, can offer a more robust and abstracted solution than traditional IAM keys, but only if you follow best practices and secure your MCP endpoints. Investing a little time in foundational training for your team now will pay dividends, smoothing out that initial learning curve and preventing misunderstandings down the line. It's about seeing MCP not just as a new tool but as the common language, protocol that ultimately simplifies your AI component interactions, turning that jumble of proprietary plugs into a single, seamless connection. Next, we'll put your understanding to the test with a quick concept check.
Alright, we've walked through the watchouts and the core ideas behind MCP. Now let's see how much of that fundamental understanding stuck. This is a quick concept check, a mental ping to ensure we're all on the same page before we move deeper.
Remember our central analogy. MCP is the universal adapter and common language protocol for AI components, turning a jumble of proprietary plugs into a single, seamless connection. With that in mind, here's your question. Which of the following is the primary problem MCP aims to solve for AI component integration? Which check it? Take a moment to think about it. Consider the challenges developers face when trying to get disparate AI models, agents, and parité data sources to work together securely and efficiently. Got your answer? The correct option is B. The primary problem MCP aims to solve is the lack of a standardized, secure communication and interoperability protocol for diverse AI components. Now, why is that? While individual AI models might lack robust security features or require specific hardware, those are often symptoms of a deeper problem, the communication chaos. You might be thinking, but I already use APIs for integration. And you do. But APIs are often custom-built, requiring significant effort to manage authentication, authorization, and data schema translation for each new connection. In real systems, this shows up when you're trying to integrate a new language model, agent with your existing vector database, and a custom-built decision engine, all while needing granular IAM permissions for the agent to access specific cloud resources. Without a common language, it's like asking three developers who speak different programming languages to collaborate on a single codebase without a shared IDE or even a consistent build system. MCP provides that universal translator and secure, agreed-upon framework, making those connections truly seamless and inherently more secure. It's about abstracting away the how of communication so you can focus on the what of your AI's capabilities. With that clarified, let's look at where you can go next to really dig into MCP's technical insights. Alright, we've taken a solid first step in demystifying MCP, understanding how it acts as that universal adapter, transforming a jumble of proprietary AI components into one seamless, common language. You've seen the potential and maybe you're even a little intrigued by how it could simplify those notorious permission and integration headaches we developers face daily. You might be thinking, okay, this sounds promising, but where do I actually start building with this? Or perhaps, how does this really provide more granular security for my AI agents than traditional IAM? I've definitely felt that pain point. This initial overview is just the trailhead, and the real exploration begins with you. In real systems, this shows up when you need to connect a new LLM to a specific data source, and instead of wrestling with a dozen different APIs, MCP offers a single, coherent handshake. So if you're ready to dive deeper, to really get your hands on the code and understand the intricacies,
I've got a few pointers. Official documentation is always your best friend for the definitive technical specs.
But don't stop there.
Jump into the developer communities. That's where you'll find real-world insights, solutions to common pitfalls, and a network of peers who are also navigating this exciting new landscape.
And for those just starting out, beginner-friendly tutorials are popping up all the time, helping you bridge that gap from concept to practical application. Thank you so much for joining me on this journey into AI's next evolution. If this deep dive into MCP sparked an idea or clarified a concept for you, please hit that like button. What are your initial thoughts or challenges with integrating new AI components? Drop a comment below. I read every single one and love to hear your perspectives. And if you want to stay ahead of the curve in AI development, make sure to subscribe and hit that notification bell. For even more detailed technical guides and advanced strategies, grab the full playbook, Link is right there in the description.